You can learn a lot, it would seem, from fossils, and in the case of land-based animals, you can discover how they moved through preserved footprints. However, for aquatic animals, this becomes much harder and has been the subject of much scientific debate. Now, through a study led by the University of Southampton, it seeks to unlock this mystery, both for the history books, but maybe also for the future of marine exploration, to make these vessels more efficient and less impactful on the creatures that live in the seas today. I visited the lab at the University to learn more about this project. In a lab at the University of Southampton, the secrets of how ancient sea creatures moved through the water are being unlocked. But without a four-flippered creature in existence today, the researchers had to create a robot to simulate possible movements.
Plesiosaurs are unique because they're the only animals that we know of that have four large wing-like flippers. The flippers are similar to those of a turtle, but the plesiosaur actually has four big flippers, whereas the turtle only steers with its back ones. So paleontologists have known about this for a long time. They've known about plesiosaurs for about 200 years. And they've always talked about different ways that the plesiosaur could have swam. You can only tell a certain amount of information from the fossils. You can see the shape, the morphology, but you can't see anything about how it actually moved. To understand that, to work that out, you've got to essentially resurrect a plesiosaur somehow. And the way I resurrected that was by building a robot. What I can do is essentially get it to swim along in lots of different ways, try it swimming with both flippers flapping up and down, then try it again with one going up as the other goes down, and then measure basically how fast it can swim and how efficient it is. And then I can compare all of those swims, and I can find the best ones. And because evolution tends to make things more efficient, it tends to make things better, anything that's not close to being optimum will be outcompeted and won't pass on its genes to the next generation. So it's reasonable to assume that the kind of most efficient and most effective swimming patterns that I find with my robot were at least close to the ones that the plesiosaur would have used.
As well as helping to write the history of these creatures, this research could also have some practical elements to make underwater vessels more efficient and less invasive to marine species.
Well, it could be used as a propulsion method for submersible vehicles. So anytime you've got a propeller, or at least a lot of situations where you've got a propeller, you could replace that with a flapping wing. So you could imagine little submersible vehicles that go and inspect coral reefs or fish populations or pipelines or something, and instead of having a propeller to push itself along through the water and then guide vanes to steer it, potentially it could be more efficient, produce a higher thrust, and be more manoeuvrable and quieter.
The project has been running for 5 years and combines principles from both engineering and biology, with help from other departments from within the university as well as its partners.
Well, I've got a big supervisory team. I've got an engineering supervisor here, Bharath Ganapathy Subramani. This is his lab, basically. He runs all the experimental side of this. I've got a paleontology supervisor who's in Hungary, Gareth Dyke. There's a ship scientist, Gabrielle Weymouth, who's also at Southampton. And then we've got Colin Palmer from Bristol, who's helped on the project. And we've also got Darren Naish as well, who's just a general zoologicon. It's the intersection of engineering and biology. It's using engineering principles to investigate how animals do their thing, because at the end of the day, all of these animals have evolved in the same world in which we live. All of the forces that they have to deal with are the same forces we have to deal with as engineers when we're designing a structure or a plane or whatever it is. So it's the same three-dimensional space with the same forces. So if an animal can do something and we can understand exactly how it does it, then surely we can do the same thing.
This is Richard Stringer for That's TV.